Hello friends, today we take up the topic properties of charge. What are the properties of charge? We take up one by one. Types: positive and negative, additive in nature, always quantized, conserved in isolated system, independent of speed in vacuum, and like charges repel, unlike attract. We take up these properties one by one. First we take up types. Now there are two types of charges, positive and negative. For example, when ebonite rod is rubbed with sulfur, ebonite develops positive charge and sulfur develops negative charge. Now I repeat, when ebonite rod is rubbed with sulfur, ebonite develops positive charge and sulfur develops negative charge. Thus there are two types of charges. Now we come to second property, additive property. Charge is a scalar quantity, whether positive or negative, and is additive in nature. For example, a charge of plus 3 microcoulomb and minus 2 microcoulomb, 3 microcoulomb plus 3 microcoulomb minus 2 microcoulomb are distributed on different parts of a body as shown in figure. Total charge on the body is plus 3 microcoulomb minus 2 microcoulomb equal to plus 1 microcoulomb. Now for practice, you can have a question, assignment 1, question number 13. Calculate net charge on a body shown in the figure. So you can calculate 5 plus 3, 8, and then 2 plus 4 plus 1, 7. 8 plus 8 coulomb and minus 7 coulomb equal to plus 1 coulomb. You will get the answer like this. Now we come to third property, charge is always quantized. How we can explain charge is always quantized? First we have to understand what is quantization of charge. What is quantization of charge? So when charge exists in discrete packets, it is said to be quantized. Electric charge always exists in discrete packets. The minimum charge that exists in nature is either the charge on an electron or proton, whose magnitude is equal to 1.6 into 10 raised to power minus 19 coulomb respectively. Now when glass rod is rubbed with silk cloth in intimate contact, glass becomes positively charged and silk cloth becomes negatively charged. Now due to friction between them, some of the electrons are transferred from glass rod to silk cloth. Let this number of electrons transferred to silk cloth be n. Then negative charge on silk cloth will be minus Ne, and positive charge on glass rod will be plus Ne. Now we look at the net charge. Thus the charge developed on both will be, say, Q equal to plus minus Ne. Q equal to plus minus Ne, or Q is equal to Ne in general you can write, where N is an integer and can assume values n equal to -9, -8, -7, so on, -1, 0, +1, +2, up to +9, so on. Thus, charge lost by glass rod and gained by silk cloth is an integral multiple of charge on an electron or proton and is expressed as Q equal to plus minus Ne. The charge developed on two neutral dielectric substances after rubbing is always a discrete packet and is given by the expression Q equal to plus minus Ne. Hence, electric charge is always quantized. So, this was quantization of charge. And now we come to fraction of charge. Fraction of charge. It is believed that protons and neutrons are themselves built out of more elementary units called as quarks. Quarks are of two types: up quark with charge plus 2 by 3e, and second down quark d with charge minus 1 by 3e. A proton consists of up down quark and a neutron consists of up down quark. What is? A proton consists of up down quark and a neutron consists of up down quark. Even in one quark model, the quantization of charge is not affected. It is only step size of the charge that decreases from E to E by 3. And now assignment. A polythene piece rubbed with wool is found to have negative charge of 3 into 10 raised to power minus 7 coulomb. Estimate the number of electrons transferred from wool to polythene. B. Is there any transfer of mass? If yes, calculate the mass transferred from wool to polythene. So these are three questions, A, B, C. Here B is shown. You can take it as B. Is there any transfer of mass? C, as if yes, calculate the mass transfer from wool to polythene. Okay. Now, charge conservation. A charge is always conserved in an isolated system. Fourth property, charge is always conserved in an isolated system. First, we understand what is an isolated system. An isolated system is the system in which no matter energy or charge can either enter or leave it. And we look at now conservation of charge after understanding the isolated system. Now, conservation of charge, how we can understand it. Consider an isolated system of glass rod and silk cloth. Before rubbing, both are neutral. So, net charge is 0 plus 0 equal to 0 coulomb. After rubbing, glass rod becomes positively charged and silk cloth becomes negatively charged. This is because some of the electrons are transferred from glass rod to silk cloth. Now, then after transfer of charge, let the number of electrons transferred be n. Let this number of electrons transferred be n. Then positive charge on glass rod will be plus Ne and negative charge on silk cloth will be minus Ne. After rubbing, the net charge on glass rod and silk cloth system would be, when isolated, is equal to plus Ne plus minus Ne equal to 0 coulomb. Now, though glass rod and silk cloth develop charges, yet net charge in the system being isolated is equal to 0. Hence, it can be said that electric charge in an isolated system is always conserved. Okay, so charge in an isolated system is always conserved. Now, we can look at assignment. Continue with assignment 1. Question number 15. Charge in an isolated system is always conserved. Discuss. Question number 16. When glass rod is rubbed with silk cloth in an isolated system, charge appears on both. Explain how this observation is consistent with law of conservation of charge. Question number 17. In all nuclear reactions taking place in an isolated system, proton number is found to be same before and after disintegration. Explain. Now how you can solve question number 17. Consider nuclear reactions taking place in an isolated system as given below. First, uranium 23892 disintegrates into thorium 23490 plus helium 42. Before disintegration, number of protons is equal to 92. After disintegration, number of protons is again equal to 90 plus 2 equal to 92 here. Okay, before number of proton is 92 and after it is 90 plus 2 equal to 92. Now, second example you can take. Mercury 280 when added with a proton. Mercury 280 when added with a proton becomes Rs 19779 plus helium 42. Now, before disintegration, number of protons is equal to 80 plus 1, 81. And after disintegration, number of protons is 79 plus 2 equal to 81. Thus, the number of protons before disintegration and after disintegration are same. Now we take third example. Uranium 23592 when bombarded with slow moving neutron is separated into barium 14156 and krypton 9236 with 3 neutrons, fast moving neutrons 1 and 0 plus 200 million electron volts of energy. Now, before disintegration, number of protons are 92. After disintegration, number of protons are 56 plus 30, so equal to 92. Thus, here also number of protons before disintegration is equal to number of protons after disintegration. Now, we come to pair production. Now, what is pair production? A gamma photon of energy hν materializes into an electron E minus and a positron E plus. So, when a gamma photon of energy hν materializes into an electron and a positron. Now, before disintegration, charge on gamma photon is 0. Before disintegration, charge on gamma photon is 0. When E minus and E plus annihilate, it generates a gamma photon, that is E minus plus E plus E minus plus E plus is equal to gamma photon. Now, after disintegration, again net charge is equal to 0. E minus plus E plus equal to 0. So, I repeat, when a gamma photon of energy hν materializes into an electron and a positron, then before disintegration, charge on gamma photon is 0. After disintegration, again net charge is equal to E minus plus E plus equal to 0. So when E minus and E plus annihilate, it generates a gamma photon. That is E minus plus E plus equal to a gamma photon. Now we come to charge. Fifth property, charge is independent of speed in vacuum. Charge is independent of speed in vacuum. Now charge is independent of speed of the body in vacuum, whereas mass of the body depends upon speed in relativistic mechanics. So its effective mass is equal to rest mass divided by under root of 1 minus v square by c square. Okay. So mass of the body depends upon speed in relativistic mechanics and is given by the expression me equal to m0 divided by under root 1 minus v square by c square, where me is effective mass and m0 is rest mass. Now we come to sixth property. Like charges repel, unlike attract. Now charges now look at the diagram or consider the following experiments. A glass rod here rubbed with silk is freely suspended from a rigid support. In the second case, a bonite rod rubbed with polythene becomes positively charged. When brought near it, it repels the rod. Okay, because both have positive charges. So like charges repel. Now a bonite rod, in the third case, a bonite rod rubbed with acetate strip becomes negatively charged. When brought near freely suspended positively charged glass rod, it attracts the glass rod, freely suspended rod, because the diagram shows that it is shifted towards the negatively charged ebonite rod. So this shows that the like charges repel and unlike charges attract each other. Okay, in the second case glass rod is repelled, and in the third case glass rod is attracted. These experiments show that like charges repel each other and unlike charges attract each other. Okay. Now assignment, we continue with assignment 1. Question number 18. Why a comb when run through one's dry hair attracts small bits of paper? Question number 19. Explain principle of photostat machine. Explain principle of photostat machine. And then you try to give answer to these questions. And thank you so much. Tomorrow we'll take up next part, gold leaf electroscope and difference between mass and charge. Thank you once again. God bless you.